Alright, so let's consider our next example. We have Usha, who is a very good swimmer. She's swimming in a swimming pool from one end of the swimming pool, which is my point A, to another end of the swimming pool, which is my point B. And that distance from A to B is 90 meters. It is given in the problem that Usha covers 180 meters by traveling both ends. Meaning what? She's traveled from A to B in a straight line, 90 meters, and she's traveled in reverse. She's changed direction and traveled from B to A another 90 meters. That's what makes it 180 meters. And this journey of 180 meters by Usha has been completed in 1 minute. I now have to find the total distance and the total displacement. Or I have to find average speed and average velocity. So first, let me talk about average speed. How is my average speed defined, guys? It is defined by total distance upon total time. What is the total distance covered? 180 meters. Does the direction or anything matters? No. For a speed quantity, no, because the speed is a scalar. It is not dependent upon direction. It is dependent only on magnitude. The total distance covered by Usha is 180 meters. How much time has Usha covered the distance in? She's covered the distance in 1 minute. 1 minute works out to how many seconds? It works out to 60 seconds. Why have I taken the unit in seconds and not minute? Because SI unit of time is seconds and it is not minute. So the average speed works out to 3 meters per second. What about average velocity, guys? It works out to total displacement upon total. Once again, the total time is 101 minute or 60 seconds. Mind you, now I have to consider the distances covered in both directions. Let's talk about A to B. The starting point was A. The distance covered from A to B has been 90 meters. Because the starting point was in a straight line till B, the direction is the same and constant throughout till B. So the displacement will be added as plus 90. However, at B, there is a reversal in direction, and after reversing the direction, it goes back to A. So there is another addition, but of opposite direction. Negative of 90 is added to denote a change in direction, because displacement is dependent upon direction apart from magnitude, it being a vector. So I get 90 minus 90 upon 60 seconds, 0 upon 60, so it is 0 meters per second. This tells us another thing about vectors, or another difference between scalars and vectors. A scalar will be positive value of positive magnitude only. The magnitude of a vector can be positive, can be negative, can be zero. So now I have three essential differences of scalars and vectors. Scalars dependent on magnitude only, vectors dependent on both magnitude and direction. Scalars are positive only, vectors can be positive, negative or zero. Scalars, example distance and speed. Vectors, example displacement and velocity.